All right. So we're going to do, we're doing number 25 off the practice problems. So chemistry 1, practice problems 11-3. Okay, we're starting with number 25. Okay, before I go into this, I want to talk about the difference between the two types that I told you. The percent yields that give you one reactants, percent yield that give you two. I don't want to confuse people, but I also want people to sort of understand what's going on. So on a percent yield, does anybody remember what the equation is or like what we need for it? Good. Actual over the theoretical times 100, right? And they have to give us which part of this, like in the problem. Yeah, good. The actual has to be given to us, correct? Now, the other thing that's important to remember about the percent yield is this is always for product. It's for product. Okay, and I know, sorry, I know it's kind of hard to see there. Okay. Now, why am I stressing this? Well, that can help you analyze the percent yield problem. So take number 25, for example. We look at it. It says, determine the percent yield for the reaction between 15.8 grams of NH3 and excess oxygen to produce 21.8 grams of NO gas and water. These are one of the most common ones that people screw up because people get in a rhythm and they see two numbers, so they automatically start doing limiting reactant BCA chart with the two numbers. Okay, but that's going to really screw you up because those actually both aren't things that you would look for limiting reactants. So this is why I'm saying a percent yield is always about the product, and they have to give you the actual. So my best advice for solving percent yield problems is the first thing you should do is find the actual. Do that first, okay? So if we look at this, does anybody know what our actual is? Yeah. Okay, how do you know? Yeah, okay, sorry. I know what you're mean. How do you know? Yes, good. 21.8. So the actual is 21.8 grams of NO. Okay, now the reason I wrote that in red is because we're not going to use that right away, but I just want to mark it down so we have it. And the reason we're doing that is because you don't use the actual until the very end when we need to divide actual by theoretical. So by identifying the actual, we can actually remove that from our thinking about using it right away. We're not going to use that till the end when we do the percent yield equation. All right, that can help you realize what you need to do at the beginning then. Okay, so if you are given three numbers, this is just for percent yield. If you are given three numbers, one of them is actual and the other two should be reactants, which means you have to run, you have to find the limiting reactant, run a BCA chart, and then do like what we were doing to get the theoretical, okay? If you only have two numbers on a percent yield, one of them is actual, meaning they only give you the amount of one reactant, okay? This actually, it requires you doing a little analysis and actually knowing what you're doing and thinking about it, but the ones that only give you one reactant are actually easier to solve. It's less steps. Okay, here's why. They're already telling you, so like in number 25, they are already telling us that NH3 is the thing that runs out first. We don't have to figure that out. They're already telling us, hey, this is the one that runs out first. This is your limiting reactant. Okay? In a case where they tell you the limiting reactant, for the percent yield, we are trying to mathematically calculate the theoretical, correct? So they're giving us our limiting reactant amount. We need to find the amount of grams of NO that should make. This is the amount that it actually make. We need to find the amount that this should make based on the math. So what this becomes one of the recipe problems, like this thing. We're starting with our limiting reactant. We are in mass and grams of our beginning thing. We need to get it into mass and grams of our new thing, our product, our theoretical. So this goes back to stoichiometry, just converting mass of our first thing to moles, moles of our first thing to moles of our new thing, moles of our new thing to grams. Okay? So all we're doing is we're taking our, see if I can get this so you can see both parts. Okay, so all we're going to do is take 15.8 grams of NH3, and you should be writing this down and following this. So 15.8 grams of the NH3, and we're eventually going to try to get into grams of NO. But first, so we've got a few steps. So we're going to do grams of NH3 is on the top, so that comes on the bottom. We're turning it into moles of NH3. Okay. The grams, remember, grams to moles is always 1 mole, do the molar mass. So nitrogen is 14, hydrogen is 3 times 1, so 17. Okay. So now we're in moles of NH3. Next step, moles of NH3 on the top, so moles of NH3 on the bottom. And we're turning it into what? Of, good, moles of NO, because that's what we want to get the theoretical in. The same thing that our actual is in. Anybody remember how we get the numbers in front of the moles? Good, coefficients. So in front of NO in our reaction, we have a 4. Right? In front of NH3, we also have a 4. Doesn't always end up like that, but here it does. Okay, and one more step. Moles of NO on the top, so moles of NO on the bottom. And we're turning it into what? Grams of NO, good. Grams of this, nitrogen is 14, oxygen 16, so that's just 30. And this. All right. So this comes out to be, with significant figures, 3, so it'd be 27.9 grams of NO. Okay, this is our theoretical, right? This is the amount that the math says should have been made. Okay. So we're going to take the actual from the problem. So percent yield is the actual from the problem, which is the 21.8 grams of NO, divided by the theoretical, 27.9 grams of NO, times 100 to get a percent. And 3 significant figures kicks us out 78.1%, or percent NO, either way. So that is shorter than having to run the whole BCA chart. And it's because we only have one reactant, we can do it that way. Okay. Any questions on that? Yeah.
If you have 2, could you
Okay, so did you watch the okay, well when I did the I think it was in the percent was it in the percent yield? It was either in the percent yield video lecture or in the BCA chart one. Did you watch the second way at the end? The like I showed one way of doing it, and then I said if you want, you can hang around for the second way. Okay, that's fine because what you're asking is actually that second way. Um, there is a way basically in what you do, um, where if you have two, you can use that to figure out without having to run through the BCA chart. Um, I'm going to do number 21 with you guys here too. And when I get to that point, I'll kind of point out what you're talking about. Okay. All right. Any other questions on 25? All right. Let's do wait, what time do we get out of here? 49? Okay. Um, here, I'm gonna